Hello, and welcome to Itasca Waters' Practical Water Wisdom Series. I'm Brian Whittemore, your host for today, and today's program is our changing water quality in the Itasca County area. Itasca Waters is a local nonprofit headquartered in Grand Rapids, Minnesota, with members who either live or vacation in our area. Our goal is to continue to find interesting ways to educate residents in Itasca County about how to keep our water clean for both the environment and the economy. You can read about our projects on our website at itascawaters.org. If you have an interest, please consider joining us and becoming a member or a volunteer to help support programs such as this. We thank our partners shown on your screen for their continued support in producing this program. Today's program will work as it usually does. Our guest will speak for about 30 minutes, and then we'll answer questions from you. To submit a question, you only need to click on the Q&A button at the bottom of the screen and type in a brief question. You can do this at any time, and we will read the questions on your behalf. We will not be using the chat function. This program is being recorded and will be available for viewing online through our website, itascawaters.org. Also, we value your opinion, so please click on the survey link, which will be on screen at the end of today's program, or complete the survey that will be sent to you by email. Thank you for doing that. Jack Jones is an internationally recognized and award-winning limnologist and ecologist who has worked on the major questions of eutrophication and nutrient pollution for over 4 decades. He was among the first to discover the phosphorus-chlorophyll relationship in lakes, which is now the backbone of lake management worldwide. In addition to working on and monitoring lakes across the Midwestern United States, Jack has been instrumental in assisting communities in Nepal and elsewhere around the world in sustaining fisheries in lakes. He's a Curator's Professor Emeritus at the University of Missouri, Columbia, and is an adjunct professor of extension at Minnesota Sea Grant at UMD. He was the founding editor-in-chief of the scientific journal Inland Waters. Jack is a summer resident of Deer Lake and a longtime member of the Deer Lake Association. Welcome to Water Wisdom, Jack.
Let's get started. We're going to talk about water quality in Itasca County lakes, and it's going to be a primer on lake water quality with emphasis on water clarity. We're going to address 4 points using data from Itasca County lakes. The first thing we're going to do is overview factors determining what lake water looks like. Not all lakes appear the same because the clarity and the color differs among them. We're going to assess patterns in individual lakes, the temporal changes in clarity within individual lakes. We're going to account for why lakes differ in clarity and venture into a light touch on lake modeling. And then at the end, we're going to talk about what we can do to protect our lakes. So trust yourself. Lake water quality can be judged visually. Our first impressions are really trustworthy. It turns out the human eye is excellent at detecting lake water quality because it discerns clarity and it discerns color. And both characteristics are important to lake water quality. And in fact, they're a response to the factors that drive lake water quality. Most of the people on this video will be familiar with the Secchi disc. It's an easy, reliable, and repeatable measure of water clarity. It's a black and white disc, and it's lowered into the water column until it's no longer visible. It's called the vanishing point, where the disc disappears, and we simply measure the rope, the length of the rope, the distance to the vanishing point. And it's got a tremendous amount of physical evidence for validity. It's used by scientists and citizen volunteers in lakes and oceans all over the world. It's got a really interesting history, and I encourage you to Google Secchi disc, because the first Secchi disc was actually one of the Pope's dinner plates. So it was first used in the Mediterranean. In lakes, measurements range from just a few inches to over 75 feet and beyond. And I personally have measured Secchi transparency of just a couple inches in an Iowa lake where the algae just made the disc disappear in just small distance. Also, I've measured Secchi transparency in a lake, Gates of the Arctic National Park. I stood on the floats of a float plane and measured a 50-foot Secchi transparency. The Secchi disc looked like a little dime on a string in that clear water. And that measurement pretty much matches the Secchi transparency of Lake Superior out in the middle. So let's talk about lake color, our perception. Blue lakes are associated with excellent water quality. We value our blue lakes here in Itasca County. Well, why are blue lakes, why do lakes appear blue? Turns out that sunlight penetrates the water column and it undergoes absorption and scattering. And it turns out that blue light is the least absorbed by the water molecule. All those other wavelengths of light that you see in the rainbow are absorbed first. Blue light remains. And so blue light is scattered back to the surface. There are other factors like the sky, etc. But the main thing is that the water molecule does not absorb blue light, but it removes everything else in the visible spectrum. So if we were to fill lakes with pure water, they'd just look blue. But that's not reality. Lake color. Number 2, green lakes have reduced water clarity. Why? Well, it turns out lakes are not pure water. They produce organic matter, and we know algae, plants, invertebrates, and fish, the food web, the food chain, it's present in every lake. And it turns out that that organic production releases organic matter, dissolved organic matter, into the surrounding water. And that organic matter selectively absorbs blue light. So what we can think of is organics actually shift the scattered light from blue to green. And we know that green lakes have high levels of both nitrogen and phosphorus, the plant nutrients. We're going to come back to those in just a second. But the higher the nutrients, the greener the lake. There is scattering of green light. There are algal cells that scatter the light, and the algal cells are green. So productive lakes look green. So let's do a few water quality facts. So let's go back to nitrogen and phosphorus. Both are plant nutrients. They grow our crops, they make suburban lawns green, and they grow algae in lakes. They determine the organic production in lakes. And it turns out that phosphorus is most typically the limiting nutrient. There's carbon present in lake water. Nitrogen has a gas phase, so it can be captured and cycled in lake water. But phosphorus doesn't have a gas phase, and it's the limiting nutrient. And when I taught classes at the University of Missouri, I'd get to this point in a lecture, and I'd say, okay, phosphorus is the limiting nutrient. Think of the chair you're sitting in. If we had 10 frames 6 seats and 2 backs. How many chairs could we construct? 2, because we're limited by the number of backs in this equation. Phosphorus is the equivalent of those backs. You add more backs into the supply line, and you can build more chairs. You add more phosphorus into the lake, and you can build more algae. Okay, algae are really tedious to count, and we get around it by filtering lake water onto a filter and extracting the photosynthetic pigment chlorophyll. And we can measure that pigment, and it is related to the nitrogen, the phosphorus, and is a measure of the organics in the lake water. Another thing that's really important is that the concentrations we're talking about of nitrogen, phosphorus, and chlorophyll are vanishingly small. They're infinitesimal. We measure these in parts per billion, or can express them as micrograms per liter. That's the equivalent of $1 out of a billion, or 3 seconds out of a century. So measuring nitrogen, phosphorus, and chlorophyll in lake water takes really good chemical techniques, really good instrumentation, and skilled technicians. Okay, we're in Itasca County, and it is in northern Minnesota. It's characterized as the Laurentian mixed forest or northern lakes and forest area. The surface area of Itasca County is about 9% water, and about 1,000 lakes of various types can be counted in the county. And about a dozen years ago, I worked with Dr. John Downing of Sea Grant, and we sampled 152 of Itasca County's most prominent lakes. And that data set is going to be the backbone of what we talk about today. Okay, here is the Secchi transparency in Itasca County lakes. And so we have number of lakes on the y-axis. We have the average Secchi transparency in feet on the x-axis. And you can see we have pretty much a bell-shaped curve. Remember, for Secchi, high values are desired. That means the lake is very transparent. So in Itasca County, we have lakes with less than a 4-foot Secchi transparency. We have lakes with greater than 20, up to 40 feet transparency. The overall average is 10 feet, and the median is 10 feet. And if we go to the EPA's National Lake Database, the median lake, average lake in Itasca County is within the top 15% of lakes nationally. In other words, 85% of the lakes in the nation are less transparent than the average lake in Itasca County. That's really good. We value our lakes. They tend to be blue. And it turns out that the clearest lakes are in the top 2% nationally. So we've got a tremendous resource. So let's remember, Secchi transparency, high values are decided. Okay, now we're going to go to some data. And I pulled these data from the Minnesota Pollution Control Agency, and there's a trend line. What we've got is water clarity increasing on the y-axis, and we have years on the x-axis, and we have a stack of points for in any given year, and these are the individual observations of that particular season in this lake. This is Caribou Lake, and it's a remarkably clear lake. It's off Highway 38 near Marcel, and it shows the typical variation that we find in Secchi transparency. Over the recorded history, there's typically a factor of 2 difference between the maximum values and the minimum. Now, there is a general perception that transparency is decreasing in the region. Lakes are less transparent than they used to be. The working hypothesis is that the airshed has changed. The Western fires have contributed nitrogen and phosphorus. The smoke has both nitrogen and phosphorus. Intensification of agriculture in the Dakotas is likely a factor, bringing nutrients into the region. Warming be a factor. But let's look now at the data from Caribou Lake. Notice I flagged some values that I think are probably a coding area in the data set. Caribou Lake is tremendously clear. It's one of the clearest lakes in the county. And notice many of the values were over 40 feet of Secchi transparency. Again, a dime on a string. But notice between the year 2000 and 2010, we've got some maximum values, and the minimum values are around 30 feet. Let's move into 2010 and beyond, and we've got fewer maximum values, fewer values over 30 feet, very few values over 40 feet, and a number of values below 30 feet. Now, this is still a clear lake, but obviously there is a decrease in its transparency. By the way, I didn't mention this is the state's trend line. It's kind of a running average, and we'll see this again in some other plots. So a slight decrease, but certainly not the number of really transparent values. So let's talk about the variation that we've just seen in Caribou Lake. We've got the types of variation, and with individual years, we saw that transparency varies. We'll talk about that in a minute. We see a variation over years, and both of these sources of variation complicate our ability to detect trends. No one Secchi disk measurement marks a trend. No one season marks a trend. It takes a lot of data over time to detect trends, and that's what we're in the business of doing right now. So what are the sources of variation? Well, there are small variations among observers. And the distance between your eye and the lake surface is important. And when I had students out in the field, I had them sit around the John boat. I took a Secchi measurement, and then I passed the Secchi disc around. Everyone took a measurement, kept the number to themselves, and it was typically within just inches of one. Everybody put their eye about the same distance from the lake, the water surface. Time of the day can be important. Midday measurements tend to be a little deeper than early in the morning or late in the afternoon because of the angle of the sun. The time since the last wind is important because we all know that wind events will disrupt shoreline sediments, etc. And there's a little more to it that we'll get to. Biology is important. We're going to talk about grazing, and there are occasional algal blooms. Occasionally, all the conditions are right and algae just proliferate. And when that happens, the lake is less clear. Physics is also important. We all know lakes stratify, and lake stratification adds to the differences in clarity over time. So here's a cartoon, and it shows that the food chain influences lake water clarity. Grazing by invertebrates is really important. And actually, let's go to the lower panel. When we have top carnivores, fish eating fish, walleye, and they're eating sunfish or young of the year fish and keeping this box, this population down, we don't have grazing pressure or extensive grazing pressure on the invertebrates, the zooplankton, sometimes called the water fleas. And these are the filter feeders that graze down the algae. So when we have fish eating fish, we have an abundance of large zooplankton, which are effective at grazing down the algae. Let's go back to the top panel now. Let's eliminate or reduce the number of fish eating fish. In that case, we end up with a lot of sunfish, we end up with a lot of young of the year fish, and we graze down the invertebrates, the water fleas that graze on the algae. So we have a proliferation of algae. And actually, these two panels can be lakes of similar nitrogen and phosphorus concentration, but the fish make the difference. Also, there is an important factor seasonally, because before, very early in the spring, before fish start feeding extensively, there's a proliferation of large zooplankton and a shortfall, a diminishing number of algae in the water column. It's the clear water phase. So that adds to the seasonal variation within a lake that we measure. Also, we all know that lakes stratify. Every one of us has jumped off the dock and penetrated the cold water below. Okay, let's realize that we have many of our lakes are very clear, and sunlight is going to penetrate through that warm layer and hit the cold layer. So with sunlight, nitrogen and phosphorus, we can form algal layers below the surface in those cool, denser waters in our stratified lakes during summer. And this XY diagram just illustrates that with depth, the chlorophyll, the photosynthetic pigment, can increase, and it's associated with the cool, dense waters. And I've measured, they're called metalimnetic algal peaks or subsurface maximums. And I've actually measured about 3 parts per billion chlorophyll at the surface and a very narrow peak of up to 100 parts per billion of chlorophyll. So these can be quite dramatic. I've also dropped a Secchi disc through the warm surface waters, the waters that are mixing, into that metalimnetic algal peak and had it disappear immediately. The vanishing point can be very abrupt. I mean, it's quite surprising. Pull the disc up and you can see it, drop it a few inches, and it's in this algal peak. So that determines what kind of Secchi transparency we measure, and that will vary over the course of the season and adds to the variance that we're seeing. Also, wind events, and we all know this, can disrupt that warm layer and bring these subsurface algal cells to the surface, which changes the characteristics of light and scattering and lowers the Secchi transparency. So within a lake, this adds to the variation we measure during summer. Okay, let's look at Deer Lake near Deer River. I'm looking out at it right now. And there, again, I think there's a coding error in the state's data set. But this is one of those lakes. And the trend line is running along here. And notice the conditions were fairly stable between 2000 and 2010. There was a peak of quite transparent water and then a diminishing value. Maximum has declined in Deer Lake. And this is one of the most extreme examples that I found in the county. And the recent measurements, again, are down here less than 20 feet. Previously, there were some 20 to 30 foot Secchi transparencies in this lake. Now we're seeing a lot of values in the mid-teens, and it turns out that Moose Lake shows a similar pattern. So we have detected a little decline in caribou, detected a decline in Deer Lake, Moose Lake, and here's Blue Water. And Blue Water is just to the east. It's part of the Wabana chain. And this is a lake that's very interesting because it's extremely transparent. Values are Secchi transparency is greater than 20 feet, up into the 25, approaching 30 feet, highly variable within any given year. But again, let your eye go from 2000 to 2010, and we see a lot of values here that are in excess of 25 feet. Let's go more recently, and those extremely deep Secchi transparencies have declined across seasons over time. And we see a few more shallow values. It's all part of our concern over a regional change in transparency, likely tied to the airshed, likely tied to climate warming. And, nutrients are picking up in Lake Superior, which indicates that the airshed is a factor. Okay, now as I cruise through data from all the lakes, North Star Lake is showing a different pattern. It's an increase. And actually, I wonder if there isn't just a bit of an change in the observers. There's a paradigm for lake water quality. Phosphorus loading determines in-lake phosphorus, determines algal biomass, determines water clarity. So Secchi transparency is in response to phosphorus loading. This is an illustration, a little cartoon to emphasize that. It's actually a diagram I used when I interviewed at the University of Missouri 50 years ago, so it's old. Tributary determines in-lake phosphorus, it cycles, it goes to the sediments. All lake sediments have a lot of phosphorus, and goes to and phosphorus is lost to the outflow. I had to add a little arrow here. There is some internal loading, but annual external inputs determine in-lake concentrations of phosphorus, and the goal is not to increase that. Okay, Itasca County phosphorus, low levels are desired, and it turns out that the median value is 13 parts per billion. And it turns out that if we go to the EPA data set, only 15% of the nation's lakes have values less than the median in Itasca. So low values are desired. The lowest values are in the top 2% nationally. Let's go to chlorophyll. Turns out that the median value is 3 parts per billion. Again, low values are desired. And the median value of 3 parts per billion is in the top 15% of lakes nationally. Have you caught the pattern? Low phosphorus, low chlorophyll, top 15%, and transparency is in the best 85%. There's an inverse relationship between phosphorus, chlorophyll, and transparency. And again, we have some of the best lakes in the nation here in Itasca County. Okay, there is a very quantitative relationship between phosphorus and chlorophyll. Phosphorus is the causal variable. Chlorophyll is the response variable. These data have been log transformed to linearize them. But as you increase phosphorus, you increase chlorophyll. And actually, this panel is the world's lakes on this same axis. So the Itasca County lakes fit into the global pattern down here. As phosphorus increases, chlorophyll increases. Okay, one more panel here, and this one is, I reversed the axes on you. So I've got chlorophyll, remember, that's a measure of algae, increasing across the top. We've got Secchi transparency, water clarity, decreasing along the y-axis. And as you can see, there's a curvilinear pattern in the Itasca lakes, which is observed worldwide, that as you increase chlorophyll, you decrease water clarity, and very rapidly at the low end, where many of our lakes are. And this is the inset panel, just further illustrates the average Secchi transparency, and it decreases from in excess of 20 feet to less than 10 feet over a very small range of chlorophyll, 0.5 to 3 or 50 cents to $3 out of a billion. So very small changes in phosphorus make changes in chlorophyll and dramatic changes in water clarity. So again, phosphorus loading determines in-phosphorus values, determines algal biomass, determines water clarity, and it accounts for differences among lakes, but it also accounts for differences within a given lake over time. So how do we protect and improve lake water quality? Not too much we can do to the airshed except hope for fewer wildfires, better farming methods in the Dakotas, control of climate change, etc. But we want to control external phosphorus loading to our individual lakes. The goal is to hold the line or reduce. We can't do too much about the external load. Maybe some watershed mediation. Can't do too much about precipitation. But locally, what we can do is septic tanks. All of us are responsible for the septic tank that is associated with our lakeside cabin. We've got to make sure that they are constructed to code, that they do not, that they match the occupancy of the dwelling, and that they're pumped, etc. The other thing is shoreline vegetation. Natural lakes are surrounded with forest. That forest serves as a filter, and it removes nutrients and sediments from water moving from the land to the lake. My cabin on Deer Lake has a completely forested, vegetated shoreline, except for a narrow 3-foot slit to get to the dock, okay? And that vegetation is there to intercept nitrogen and phosphorus. And there are programs in Itasca County to assist both septic tank assessments and shoreline. So what I want to leave you with is science has made huge advances in the past 5 decades to understand factors that are controlling conditions in the open lake, the clarity, the algal biomass, etc. We're currently working on what regulates algal growth along the shoreline, the stuff that you see. It's still tied to nitrogen and phosphorus, but our models are not yet fully developed. So I want to leave you with the data source, our Lakes and Stream Water Quality Dashboard of Minnesota Pollution Control Administration. You can look up lake data there. There's some nitrogen data, phosphorus data. I just concentrated on clarity for simplicity. So let's open it up to questions.
Okay. And thank you very much for that portion. Extremely cool, instructive, I should say. And now it's time for the Q&A portion of today's program. It'll be hosted as usual by Bill Granches, the director of the Itasca County AIS program and a longtime member of the Itasca Waters Board of Directors. Bill?
Thank you, Brian. Welcome everybody to the Q&A section of this program. Now, as before, I want to remind everyone that we are not using the chat function. If you want to submit questions, as several people have already, use the Q&A button at the bottom of the screen. Now, it's possible that we may not get to all of your questions during this program. And if that's the case, please feel free to send us an email with your question, and we'll be sure to get back to you. And that's itascawaters.org. Okay, Jack, here comes the first question. Oh, it's a good one. Could the increase in clarity in North Star be related to zebra mussels that arrived in 2017?
Yeah, and I did not go into that, but zebra mussels are changing the food web. They're changing it from pelagic to benthic, and that is a really good suggestion. Yeah, and that
Very good.
I agree.
Okay. Next question from submitted anonymously is, so if big fish reduce algae concentrations and increase clarity, could overfishing or intensive fishing make lakes murkier?
Yeah. Well, we certainly want to maintain a healthy top predator fishery. And my impression is this is done pretty well in Minnesota. And I don't fish, but I've talked to a lot of fishermen and asked them about the top predators in Itasca County lakes. And nobody has said that there's a dramatic change or decrease. So I think that's fairly stable. It looks like the harvest and the populations are in balance. And that's not quantitative, that's a qualitative assessment.
Very good. Next question came in. Is it conceivable that the proliferation of Western US and Canadian fires over the past several years contributes to the declining clarity of lakes you've been discussing?
You know, it's a really good working hypothesis because if you look up nitrogen and phosphorus in forest fire smoke, it's there, it's been documented in the scientific literature, and the tick up in nutrients in Lake Superior indicates to me that there's something going on in the airshed and we're picking it up before it gets to Superior. And, you know, the cascade of nutrients to algae to clarity we've reviewed.
Thank you. Carolyn asks, is there any data of the clarity of the pit lakes just for comparison?
I didn't go that far. And this is a qualitative presentation of conditions in Itasca County. I'd be happy to pursue that if the data are out there. The pit lakes may not have volunteer samplers. Okay.
All right. Next question. How can I go about testing the quality of the lake I live on for phosphorus, nitrogen, Yeah, and sorry, and chlorophyll.
There are a couple labs in the area that do this kind of testing, including a lab at the University of Minnesota Duluth, and I'd be happy to send those contacts.
Very good. I'm not sure about this one. That's new to me. Anonymous question asks, why does Minnesota use all white Secchi discs versus black and white?
Um, both are used, and
Yeah,
there is not much difference between the two of them. The black and white is kind of helps in distinguishing that vanishing point, but I've used both the black and white and the white in a range of lakes, and the measurements are virtually the same.
okay,
But I know the standard here is white. And remember,
right.
I've just moved to Minnesota.
But you live on beautiful Deer Lake,
I did,
so that
and
makes up
had
for
for
it.
30 years.
Very good. All right, here comes a question from someone watching from Becker County. This year in Becker County, our lakes all experienced multiple algae blooms and increased density of aquatic plants near shore, affected swimming, open water access. Also, do you know of any monitoring protocols for testing phosphorus near shore versus only in the deep areas on a lake, especially those with zebra mussels?
Yeah, that's a complex question. Let's take the first part. It's been a really wet year. And if we go back to that silly little blue and white diagram that I used to interview at the University of Missouri, the loading determines the in-lake phosphorus concentration. My hypothesis would be that the storms, the early spring and early summer storms delivered nutrients to those lakes, and there was a proliferation of algae in the center. Probably it also contributed to the growth of vegetation along the shore. And that, as I ended, is our goal is to better quantify that response. And yes, there can be differences between mid-lake and shore. It it may not be as great as you might think over the long run because there's an exchange of water based on heating, and the warm. Everybody knows the lake water warms during the day, and there's a convection along the shore. So there's more mixing there than you might expect. There are differences among bays in these complex lakes in Minnesota. Some bays had more development, more inflow, and higher nutrient concentrations. We'll let it go at that.
Okay, very good.
Good question.
Yeah. Here comes a question from Wabana Lake Association. Someone on Wabana Lake, Dave. Wabana Lake Association did a septic compliance drill around 2000. 70% of systems were non-compliant. Currently, it is estimated that 40% of septic systems are non-compliant in the county. It has been difficult to invoke septic compliance. Do you have any ideas on how to convince lakeshore owners to have a compliance inspection completed, and if non-compliant, install a new system?
Just do the right thing. I, you know, I have limited experience dealing with the general public on this issue. I think education helps. Some people are going to be resistant. It's not my problem. But I think the vast majority people who live around lakes in Minnesota treasure them and want them for generations to come. Just do the right thing.
Well, I know Deer Lake has a high number of compliant systems, and I know Wabana is had spectacular results in their efforts there too. But it is a problem in Itasca County and all other counties as well. All right, next question we have. A couple more minutes here. You didn't mention lakes that look brown, a root beer shade. What causes that?
They're called humic lakes, and that's related to the nature of the soils, the number of wetlands in the watershed, and those organics are kind of like a tea bag, essentially, and they're resistant to bacterial breakdown. I talked about organics in lake water, and the organics absorb blue light. Well, those organics break down by bacteria. It's called labile. The humic and materials, the tannins and the lignin that come out of the forest in some watersheds are really resistant to bacterial breakdown. Interestingly, lakes are browning across North America, upper North America, because of climate change, warming of the forest soils, and more of these tannins and lignins being delivered to lakes. So there's a brownification of lakes. And I don't know how extensive it is in northern Minnesota, but it certainly has been recorded in New England.
Very good. Next question. Does the size of the algae affect water clarity?
Yeah, it does. It turns out that small algae scatter light more effectively than large algae. And actually, when I taught my limnology course, I used an example. Let's take a glass of water and let's put a piece of chalk into the glass of water, large volume. Okay. It doesn't really change the clarity of the glass of water. Let's take that chalk out and crush it and add it back into the glass of water. And it dramatically changes the clarity. Same amount of material, same mass, just in different size. So small algae scatter light much more effectively than large algae. And you can actually, in a lake that has large algae, you can drop the Secchi down very deep. Okay. So
Very good.
that's another source of variation. The size of the algae within or among lakes.
Very good. Christina asks, are any new efforts taking place around the area, like the one where native plants were reintroduced in Grand Rapids along the Mississippi shoreline to help improve water quality?
I have heard of that. I have not participated. That's about as far as I can go, but it's a good idea.
Right. It's a wonderful program. Okay, next question. Are you aware of other states with effective ordinances which protect shorelines or require plantings, like trees and shrubs, as part of a permit application? Our native shorelines are disappearing, and Minnesota has not improved shoreline ordinances in decades.
I've heard it discussed. I know it's effective. I've mentioned I've never pulled anything off of our shoreline. But you can go up and down the lakeshore and see where shorelines have been dramatically altered.
Yeah.
And they're usually associated with lawns coming down to the edge of the lake. Very suburban looking. I'll leave it at that.
Everyone's dream of what the perfect home on a Minnesota lake is different. And I know we're using education to try to change that. All right, enough from me. Carrie asks, what effects does high water have on water clarity? And do any of these effects continue after the water level recedes? If so, for how long do they persist?
You know, that's a really good question because that is a new research issue in limnology. With climate change, storms, etc., lakes around the world are experiencing big differences in water level. And when you increase the water level, you bring water in contact with soils that have not had water.
Mhm.
You have a greater chance of sediment removal, and it tends to be a transfer of nutrients from the shoreline to the lake. Now, those nutrients may be soluble and taken up right away by algae. Others will sediment, but it's certainly a source of nutrients. And it's a worldwide issue being modeled by limnologists currently. Good question.
Very good. Ah, okay. Next question. What has been the single most significant factor in improving water quality in Itasca County?
I would have to say the education efforts that have gone on to improve septic tanks and improve shorelines. They're holding the line. That's where that's where we as individuals can hold the line on nutrient loading. And I've constantly been impressed at the devotion and activity of both septic tanks and shorelines.
I know I was scanning through the list of people watching, and a lot of the people watching are responsible for a lot of the education that's going on. And for those of you, thank you very much for your efforts.
I would add that I know that there are some efforts to address stream flow into lakes, less channelization, working with the county to not divert water directly to lakes, but to divert them into wetlands, former wetlands.
Sure.
And that's doing the right thing.
Right. Absolutely. Okay, I think we have time for another question here. This comes from someone on Trout Lake. Some of our lakes are blue, like the Caribbean, but sometimes have lower clarity than lakes that aren't so blue. If clarity gets higher, is that a good thing?
You know, I didn't go into this, but there are certain lakes in the county that are marl lakes. They have a calcium clay, and that adds to that azure blue characteristic. Trout and blue water, somewhat deer, have that going on. And those inorganic particles
Mhm.
reflect blue light and actually diminish clarity a bit. But it's not tied to that phosphorus algal relationship. And I didn't have time to go into that. Actually, I'm not an expert in that area. And it's one of the things I want to better understand because I think we saw tremendous variation within season in Blue Water Lake, and it's tied to that marl production.
Sure.
And that marl production is tied to overturn storms, etc. So good question, yet to be resolved. It's one that John Downing and I had an hour and a half lunch talking about how to address that topic.
Sounds like a good lunch.
Sneaky.
Okay, actually, we're starting to get questions here. There are some of the things that have been popping in my head while we've been listening. This one is from Julian. Asks, what about all the salt used on roads that eventually gets into streams, rivers, and lakes?
Great question. And there was just a recent paper that came out that it turns out salt exposure diminishes the fecundity of zooplankton, the water fleas. And so increased salts reduces the number of grazers and potentially will proliferate more algae. And both calcium and sodium salts were tested in this paper, and both diminished the fecundity of water fleas. In the north, salts are used, and it's certainly not helping lakes. Again, if we can put that runoff in, not directly in the lake, there's a benefit to that. Everything we can do to filter is a benefit.
Very good. All right, I'm going to slip one last question in here. Are there any regulations you know of that prohibit the use of commercial fertilizers and pesticides, herbicides on waterfront properties?
I don't know, but I would love to see the ethic of leaving the ridiculous suburban lawn at home and having the raggiest lawn where only you need it. There's really no need to amend lakeshore property with nitrogen and phosphorus. We don't come to our lake cabins to show off our lawns. So I am opposed to lawn fertilization anywhere within a lake watershed.
Sure.
Likewise, pesticides.
Absolutely. Well, Jack, thank you for that. Brian, I'm going to turn this back over to you. Thank you much.
Okay. Thanks, Bill, and thank you, Jack. Make sure you register for our next Water Wisdom program, which comes up on October 3rd to learn about PFAS in water, PFAS, forever chemicals. PFAS in water, how did they get there and why are they so challenging to address? If you would like to watch this program again or recommend it to your family, friends, or neighbors, a recording of today's talk will soon be on our website at itascawaters.org, along with all of our previous programs. And to give us your feedback, which we'd really appreciate, please click on the survey link, which will be on screen at the end of today's program. You will also be getting an email evaluation form so you can choose how you'd like to respond. I'm Brian Whittemore for Itasca Waters, and thank you for being with us today.